before I go over the problem, I have to go over how to integrate tangent of x. So I'll start by writing this as the integral of sine x over cosine x dx, so that I can do a u substitution. I'm going to let u equal cosine of x, and then doing the derivative on both sides, I will get that du equals negative sine of x dx. And here's a sine of x dx. So if there were a negative right here, that would be pretty nice, because then it would just be my du. But I can't just put down a negative, because that would change the whole thing. But I can put down another negative right here, and then these two negatives, when you multiply them, they cancel each other out. So now this right here is my du. So now we are looking at negative integral of, so my negative sine of x dx is my du, and then I'm left with 1 over cosine of x, which is my u. And we know how to integrate this. I know that integral of 1 over u du is going to give me natural log absolute value of u plus constant. And then my u is cosine of x, so let's put that back. So I'm going to have negative natural log absolute value of cosine of x, and then plus a constant. And if you like, you can say that this is your answer, but I'm going to rewrite it a little bit the way we usually write the answer. I'm going to take this negative. Remember, this is having a negative in the front is like saying we're multiplying by negative 1. So I'm going to take this negative 1. I'm going to use the log property that says that I can put this as the exponent from the inside of my logarithm. So this is going to be equal to the natural log absolute value of cosine x to the negative first power plus a constant. Now don't put down the negative 1 right here, because that would make it look like inverse cosine. That's something else. This means that we're raising it to the negative first power. In other words, we're taking the reciprocal of it. And the reciprocal of cosine is going to give me secant of x. And then plus a constant. And this is how we usually write the answer for the integral of the tangent of x. With that being said, we can take a look at the problem. So we're given a function f of x, and we know that its derivative is the tangent of x. And we're told that x is between negative pi over 2 and pi over 2, which basically means that f prime of x is a continuous function. And given this initial condition right here, we have to find f of pi over 4. So I'm going to start by writing this down again. F prime of x equals tangent of x. And this is like an initial value problem. So I want to integrate both sides. So I'm going to first multiply both sides by dx so I can integrate. And now I'll integrate both sides. And integral of f prime of x is going to give me f of x plus a constant. I'm not going to put down the constant right now. I'm going to put it down on the other side because I'm going to get another constant when I integrate this, and I can just put them together. Integral of tangent x dx we now know is going to give us natural log absolute value secant of x, and here I'll put down a plus c. And we have this initial condition right here, so we can use that to solve for c. So I know that if I plug pi over 3 in here for x, I have to get natural log of 6. So we know that natural log of 6 equals natural log absolute value secant of pi over 3 plus c. And, well, secant of pi over 3 is going to give you 2. And if you don't see why that is, draw your right triangle and take a look at the ratio there. So I can replace this absolute, and of course the absolute value of 2 is still 2. So I can replace this right here with just a 2. So, what is c? Is it natural log of 4? No, it is not. Natural log of 2 plus natural log of 4 does not equal natural log of 6. You can't add the insides. What you actually have to do is multiply. The log property says that when you have a sum of natural logs, you have natural log of a product. So this would be equal to the natural log of 8. We don't want that. We want natural log of 6. So be careful with that. So what is C going to be? Well, I know that C is going to be natural log of 3, because natural log of 2 plus natural log of 3 is going to give me natural log of 2 times 3, or the natural log of 6 that we're looking for right here. So I know that C is natural log of 3, so I can replace this C right here with a natural log of 3. And now we have an equation here for f of x, and we can use it to find f of pi over 4. But first I'm going to erase all this extra stuff so that we have a bit of room to do that. So f of pi over 4, I can write, is going to be natural log, absolute value, of secant of pi over 4 plus natural log of 3. And secant of pi over 4, if you draw your right triangle, you should get that it is the square root of 2, and then the natural log of the absolute value of the square root of 2 is just the natural log of the square root of 2, and plus natural log of 3. And again, because you have the sum of two natural logs, you can combine them and write it as the natural log of the product, 3 times the square root of 2. I'll do it in the order that they give in the answer choices, so that we find out that the answer is choice C.